All right, let's look at some functions that are not linear and see if we can find some patterns, some shortcuts. The slope, a rate of change of a line tangent to a function like f of x equals x squared and g of x equals x cubed, is always different depending on the point of tangency. So if you look at this point right here, for this one, we have a slope that's negative and pretty steep. If we look at the vertex, that point has a tangent line that is 0, has a slope of 0. It's horizontal. And over here we have a positive slope. So you can see at those three different points, our slopes are very different. Same thing over here with the cubic. At our different points, we have very different looking slopes. So it's always changing. Let's take a look at the basic quadratic function and see what happens when we get the derivative. So let's find the general derivative here. We're taking the limit as h approaches 0 of f of x plus h minus f of x all over h. Remember, our function here is just x squared. So we're taking the limit as h approaches 0 of x plus h squared. Remember, this whole thing in the parentheses takes the place of the x. Minus f of x, that's just our function, that's just x squared all over h. So we get limit as h approaches 0. If we multiply this out, we get x squared plus 2xh plus h squared minus x squared all over h. So as always, we get a couple things to cancel out. Now we're left with a couple things up top, and they both have h's in them. To save us a little writing, I'm not going to write this out, what's left over. I'm going to go ahead and factor. We can take an h out of both of those terms. That allows us to cancel out the h in the bottom. So now we're left with the limit as h approaches 0 of 2x plus h. Well, we can do direct substitution. If we put 0 in for h, all we're left with is 2x. So that's our derivative of f of x, our general derivative. F of x is x squared. General derivative is 2x. Well, that may spark some interest. You may see a little something going on with those two if you compare those. Let's talk about, we won't go through the whole process, but let's look at what our derivative of g of x would be. Remember, g of x is x cubed. I'll go ahead and tell you without having to do all the work, the derivative of g of x is 3x squared. So take a look at what we have here. Look at our g of x and derivative of g of x, f of x, and derivative of f of x. See if you notice a pattern between those two derivatives and their original functions. On the next page, we're going to talk about what that pattern is.